Hello and welcome to the day 6 lecture for our Upward Bound Integrated Math 1. Today we're going to look at two things. We're looking at some more complicated equations as ones that we have to distribute and solve, and then also equations where we have to solve and they have exponents involved. And we'll look at those in just a little bit. The main driving force behind what we're doing today is, again, we want to look at our inverse operations. For addition, its inverse operation is subtraction. For subtraction, we would undo it using addition. Multiplication, we would go ahead and divide. And to undo division, we would multiply. Okay. Now, the reason I have them written in this order also is that this is also the order that we want to undo these operations. I want to undo addition and subtraction at the same time and multiplication and division at the same time. Now, realistically, you're going to have one addition or subtraction. It's either going to be addition or subtraction, and it's either going to be multiplication or division that you have to undo. My main goal for all of this is I want to end up with, I want every equation to have kind of three parts. And that is some number, which I'm just using a rectangle for here, times my variable, and then plus or minus, I don't care which one, some other number, and I want that to equal some number. Okay, so these are my three parts. I have my variable term, I have my constant term, and I have something that it equals. And I want to simplify every equation by combining like terms to get it into some form like this. So let's look at how we might do that. On this one, I noticed that I have four things. Remember I said I wanted three things. I want something with a variable, something by itself, and then equals something. So I have my something with the variable. I'm good there. I have two things that don't have variables, and then I have an equals a number. So my right-hand side is good, and my 2x is good, but I do need to combine these. So I want to combine negative 14 and 4. That's going to give me negative 10. So what have we done there? We have combined like terms, and it gave us a two-step equation. There's two things that are happening to x. It's being multiplied by 2 and then subtracted by 10. And that's going to be my goal on every one of these. To solve this, I'll go ahead and add 10 to both sides. And I get 2x is going to be equal to 20. And then to solve for x, I would divide by 2. And x would be equal to 10. As if there weren't enough 10s in this problem, that ends up being the answer as well. So that's okay. The beauty with equations and solving equations is there's always a possibility. If you are unsure, you could always go back and check. Of course, it takes a little more time. That's why I typically avoid it. If it was a thing that it really mattered to you, or even to me, when it matters to me, I go back and I check, is x equal to 10? Does that make sense? Well, I know that if I put 10 in here, 2 times 10 is 20. 20 minus 14, let me maybe write this a little different way. Let's write it down below. Let's say 2 times 10. And notice I am using the original problem, not what I came up with as an equivalent statement. I'm using the original problem. And I'm not going to write the equals 10 part. I'm just going to figure out what this is. And if I get 10 at the end, meaning this 10, well, way to totally mess that up. If I get this 10 at the end, then I know that I've done my job correctly. So 2 times 10 is 20, minus 14 plus 4. 20 minus 14 is 6. And 6 plus 4 is 10. So you can always go back and check your answer. Make sure you did it right. And again, since I got 10 here, and this was 10 right here, then we're good to go. It doesn't matter that my answer was also 10. I'm not looking at this one right here, looking to equal that one. I'm actually looking to equal the right-hand side of my equation. So the next one, I notice I have two things that have j's. I have 2j and negative 4j. That's going to combine to give me negative 2j plus 10 equals 12. And when I subtract 10 on both sides, I get negative 2j equals 2. And then when I divide by negative 2 on both sides, I'll get j equals negative 1. And again, you could go back and check it, and you could even do what I was kind of trying to do the first time and just kind of spot check it. I could say plug in a negative 1 here, that's going to make that a negative 2. Plug in a negative 1 here, that's going to make a positive 4. So negative 2 and positive 4 end up being a positive 2. Positive 2 plus 10 is 12. So we're good. Okay. On the next one, I notice it's a pain. I have fractions, but that's okay. I can still do the same thing. Okay, and I notice that I actually have 5 things here, so there's some simplifying that I want to do. I want to deal with the fractions with x's first, and then deal with those 2 fractions second. If I think about this 1/2 is the same as 2/4, finding common denominators. 2/4 minus 1/4 is 1/4. Those ones had x's. This 3/5 is the same as 6/10. 6/10 minus 1/10 is 5/10. Now you may be saying, hey, isn't that equal to 1/2? And it is. And you wouldn't be wrong to turn it into 1/2, but I'm going to leave it as tenths because I know I need to subtract it from both sides, and this one's already in tenths. Okay, so when I subtract 5/10 from both sides, I get 1/4 x is going to be equal to 2/10. And here, if you wanted to simplify, you could. 2/10 is actually equal to 1/5. So we can do that and make our lives a little bit easier. The way I undo this 1/4 x, I will multiply by 4/1. I want to flip my fraction and multiply. And so this side's going to cancel out, everything's going away, and I'll end up with x equals 1 times 4 is 4, 5 times 1 is 5. So 4/5. Okay. The ones down below, kind of similar. The only difference is I do have parentheses here, so hopefully that makes you think about distributive property. I need to distribute before I work at solving my equation. And I'll probably have to not only distribute, but also combine like terms. So that's going to give me 8m and 56. And that still equals 116. I'm going to combine my negative 4 and 56. So I have 8m. I'm not happy with any part of that. Let's try that again. I have my 8m plus 52 now equals 116. And then we can go 116, how about minus 52? Gives me 64, so 8m equals 64. And then when I divide both sides by 8, I'll get m equals 8. And there we go. Go ahead and pause the video and try the other two. Okay, hopefully you had a chance to get those done. For the first one, I noticed that I distribute the -4 into the parentheses, and I get -16 minus 16p equals, minus 16p minus 7, and all that equals -135. I combine my -16 and my -7 to be -23. And then I add 23 to both sides, and I get -112 equals -16p, and divide by -16, I get p equals 7. Okay. On the next one, I've distributed my -7 into the parentheses. So I get -28n minus 7 equals -119. Add 7 to both sides, and I get that -112 again, but a different number over here, -28. When I divide -28 by both sides, I get n equals 4. So you notice I'm not showing every step similar to how I did in the very first problem where I show adding 10 to both sides. That's pretty common once you get a little bit more confident with solving equations. So if you're at that stage now, you can feel free to do that. If you still need to write out all the steps, then you can do that as well. That's okay. The next part I did steal from a different version of teaching classes like this, ones that take a little bit longer. So kind of all this mumbo jumbo up top is a little bit different. We don't really see that in this class. And it's probably going to take a while to get there. So the main thing that I did want, and the reason I did steal this is the important part. This how to solve ax squared plus c equals 0. Step 1, I want to get the x squared part by itself. I want to get that x squared completely alone on one side of the equal sign. Step 2 will be take the square root of both sides, and then write the answer in the indicated form. We're just using decimals. So you can feel free to use decimals. Most of the time, we will end up with some kind of decimal as an answer. In fact, well, I kind of take that back. I've kind of set us up with some problems that work out pretty nicely. So you may not actually come up with decimals. You may get round numbers. You may get whole numbers, and that's okay. On the first one here, I have b squared minus 1 equals 35. Now I want to get this b squared by itself. I almost think about treating that like an x, and I just want to solve for x, and then I'll deal with the squared part afterwards. So I do want to add 1 to both sides, just like before. And I'll have b squared equals 35 plus 1 is 36. Now what this means, we have to think about, what does b squared mean? Well, b squared means the number b times itself. So how could I figure out what number times itself gives me 36? Sometimes that's a little bit easier to do. You can just do it, well, what times itself gives me 36? If you're good at your multiplication tables, this may be an easy concept. Alternatively, if it's a number that I don't know, I'm going to have to take the square root of both sides to undo squaring. So when I have a variable squared, and I take its square root, whatever I do to one side, I have to do to the other, but when I take its square root, it's kind of like a form of division, and that's why it looks like a long division symbol a little bit. But the square root function undoes this, and it just ends me with, this will just be b over here. So it breaks one of the b's away. And when I take the square root of 36, I am going to come up with 6. And hopefully that makes sense, because 6 times 6 equals 36. But can you think of anything else that would multiply by itself and give you 36. Go ahead and think about that for a second. So hopefully, after thinking about that, you've come up with one other answer, because there is one other answer. But maybe you didn't. I don't know. What number times itself would give me 36? I know 6 works. But because of our rules of multiplication and negative signs, if I were to take -6, wow, that was awesome. If I was to take -6, I would also get 36. And a positive 36, because negative times a negative is a positive. So that's another answer. And the way that we denote that in math is we say plus or minus. A positive or a negative would work in this case. I'm not going to require that you have the plus or minus like on a mastery challenge, but you should know that both of those work. What this means realistically is that I either have 6 or -6. Okay? So, yes, I do get the positive or the negative versions. The next problem, in order to get x squared by itself, I would divide by 81 on both sides. And this is a trick in square rooting. But I would have 49 over 81, and that doesn't simplify to give me anything nice. It's a pretty ugly decimal. But when I take the square root of a fraction, that's actually equal to, so this side's going to be x, but it's actually equal to a fraction of square roots. Meaning I can, on the top, have the square root of 49, and on the bottom, I can have the square root of 81. So you can either use a calculator or your multiplication facts. What times itself gives me 49? That's 7. What times itself gives me 81? That's 9. Now, as we just said, it does also work if I have the positive or the negative versions of those answers. So technically it should be plus or minus. On the next one, I have 7 minus 2p squared equals -91. So I would subtract 7 from both sides. And when I subtract 7, I get -98. And then I'm going to divide by -2. And that gives me 49. Now that I have the p squared by itself, I'll go ahead and take the square root. And that'll tell me that p is equal to the positive or negative 7. Okay, we found that right back here, so we just got to reuse that idea. Let's do one more together, and then I'll let you do a couple by yourself. On this one, I'm going to have 3n squared. I'm going to add 6 to both sides, so it's going to give me an 81. And then when I divide by 3, that's going to give me a 27. And then I can take the square root. And at this point, you might try to think, well, what times itself gives me 27? Well, I don't know too well. So you can use a calculator and take 27. And on this one, I have to do the square root after I put in the number. Some the calculators that I bring to class, you hit square root first. So you just have to test it out on every calculator you have. I know most like iPhone calculators are this way. You put in the number and then take the square root. I think Samsung calculators are the opposite, where I'd put in the square root first. But when I take the square root of that, I get a big ugly decimal. But that's okay. Right? That's okay. I get that equals, I don't remember what it was, 5.19, let's call that 5.2. Okay, go ahead and pause the video and try the next two problems. All right, so hopefully you got a chance to do those problems, and I did, I hate to admit it, but I did leave the hardest ones for you. And I guess I should say over here we do have a plus or minus, but yeah, sorry. I'm trying to write that every time, and I didn't. The first one that I had you do here, so we should subtract 9, get negative 370, divide by 4, get negative 92.5, and then take the square root. And if we look at taking that square root, 92.5, let's make that a negative and take its square root. For mine, you hear my computer gave me a sound, and also it says invalid input. Well, I wonder what that could mean. And if you did it on a calculator, it might say domain error, or it might say, there are a lot of different responses calculators will give. Well, this one, it turns out that if I try to take the square root of a negative, in fact, on this one, that's the only thing that's different other than there being a decimal. It's not the decimal that messes things up. And I'll show you that by taking, I wanted to take 92.5. If I take the square root of that, I get an answer. Again, it's ugly. It's not a pretty answer, but I do get an answer. So it's not the 0.5 that messes things up. It's actually the negative. And that's because, can you think of a number multiplied by itself that's going to give you a negative? Well, a positive times a positive is a positive. So that didn't work. What if I go negative? I say, well, what if it's a negative number? Well, a negative times a negative is also a positive. So there's no way to multiply the same number by itself and get a negative. This gives us an answer of no solution. We cannot take the square root of a negative number. Now, this is kind of like your early math teachers saying you can't do things like going, you can't go 3 minus 5. I remember I had a math teacher, you can't go a smaller number minus a bigger number. Well, then we learned later down the road you could, but that teacher didn't want to teach you about negative numbers. Okay, this is kind of the same way. You can actually do this, but it gets us into what we call imaginary numbers, and that's typically above an Algebra 1 level. So I'm going to save that for another class at a later date to cover. Okay, but for us, we're going to say that there's no solution. Technically, the correct answer is there's no real solution, because real numbers are a thing, as well as, believe it or not, imaginary numbers are another thing. But if you just want to shorten that to say no solution, that's fine. I'm okay with that. But that's our answer there. I know it feels kind of undone. It feels like, well, I don't really know what to tell you. That's okay. All right, that's okay. The next one, if you worked on that one, you get to the square root of 0. Well, what is the square root of 0? Well, that one a calculator would actually take, and it would tell you that the answer is 0. And that's true. The only number times itself that's going to give you 0. And this one's a little bit harder to think about because we could multiply anything by 0 and get 0. But you can't multiply anything by itself and get 0 unless that anything is in fact 0. So n is 0. Now the only difference, the only reason I say this is a little bit different than the other ones, putting a plus or minus in front of 0 doesn't make any sense. 0 is neither positive nor is it negative. It's right in the middle. It's the middle ground between the positive world and the negative world. So you don't have to put a plus or minus. In fact, in all these ones, all these had 2 answers. See, the plus 6 or the minus 6, that's 2 answers. 2 answers here, 2 answers here, 2 answers here, no answers here. And this one only has 1 answer. I'll let you think about where you can use that, but that's just an important thing to understand. Okay. When you try to take the square root of a negative, that's going to give you no solution. When you take the square root of 0, you're just going to get 0, not positive or negative. The last thing that I'll say is probably helpful to know is a list of perfect squares, or a list of your square numbers. If I think of, let's get two lists going here. Let's go to 15. And I think for this list, I just want it to be the number. And for this list, I'm going to have it be n squared. Okay, now I've got to take it out of that. And this is an important list to know. It's pretty easy to find, but it's a pretty good list to know because it can really help you out. 1 times 1 is 1. 2 times 2 is 4, or squared. That's what I'm doing here. The top row is the number. On the bottom, I'm squaring that number. What about 3 times 3? Well, that's 9. And I get 16. I'm going to have to work on my spacing a little bit. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 64. Sorry, 9 times 9 is 81. 10 times 10 is 100. 11 times 11 is 121. 12 times 12 is 144. And those ones you should know. They were all in your multiplication tables as you were growing up, and shouldn't really be that big of a stretch for you to know, excuse me, to know those numbers. It is helpful, I have found, to know the next couple at least, because it's going to get us above the 200 mark. So 13 times 13 is 169, and 14 times 14 is 196. I find those ones easier because you just change the order of the numbers. And then 15 times 15 is 225. The important thing that we find is as we get numbers that aren't, as we take square roots of numbers that aren't in this bottom list, you can really guess where it's going to be. Like on this one, I had 27, and I was finding the square root of 27. Well, I know that 27 is right here, somewhere in between these two numbers. So when I take the square root, it's going to be somewhere between these two numbers. Okay? And it was 5.2. And even that 27 is just a little bit bigger than 25, means that when I take the square root, I get something just a little bit bigger than 5. And this works out with all numbers. Granted, all these other ones I had, they were perfect squares, so it didn't really help us, or this list wouldn't have really helped us. If we look at our 92.5, in fact, let's look at the positive version so we actually get an answer. 92.5 is somewhere between 81 and 100. So I should get an answer between 9 and 10. Let's see. Oh, I didn't. There we go. I do. I get 9.6. So that's kind of interesting that you can kind of have a sense for where your answer is going to be and then verify it using a calculator. That's all I got for today. Good luck on the homework problems and the application. If you have any questions, let me know, and we'll see you in class.